Okay, we're here at gotomath.com. Let's go down to the second derivative test. Okay, so this will be the first problem for 1-1. Alright, it's asking to find all inflection points of the function here. So I've got a dot here indicating where the actual inflection point is occurring. Alright, so this is what we're going to do. Write that down and we'll head over to the whiteboard, and it's not that bad, I promise. Let's first kind of figure this out. Let's see, over 1 looks like 1, 2, 3, up 3, so our answer should be something like that, 1, 3. But okay, let's go over here. Let's write things down. We have f of x is equal to 4 times x minus 1 cubed. Oh, that 3 didn't come out right. Okay, and then plus 3. Alright, so the first thing we're going to find is the first derivative. We're going to find, so in this section here it's going to be about the second derivative. So bring the 3 out front. You got 3 times 4 is 12. X minus 1, and subtract 1, derivative the inside, bring it out, it's just 1, derivative 3 is 0. Now we're going to take the second derivative, f double prime of x is equal to, so we have 2 times 12 is 24, x minus 1, and then of course derivative the inside, bring it out, but that's just 1. And then what we'll want to do is, okay, so this is like finding the critical number, and consider this to be the original function, and now we've taken the derivative and we plug c in for x, and basically we're finding a critical number here. But anyway, so I'm going to set this equal to 0, so minus 1. Find the solutions to this, and x is equal to 1. Okay, and then what we'll do is draw a number line. Alright, and we'll put 1 on the number line, and then we'll use a test point. So this is just like increasing and decreasing. Let's use 0 is always a good one, and then our other test point will be 2. Now what you'll want to do this time is we'll take 0, plug it into the second derivative, so we're going to end up with a negative number, and that's all we care about, is if it's a negative or a positive. Okay, negative. So this indicates from negative infinity all the way to 1 that the graph is concave down. Alright, and then we're going to plug in our other test point, and all we're concerned about is if it's positive or negative. Okay, or let's see, or of course it might be undefined. So we plug 2 in, so we get a positive number. Like I said, we don't really care what the number is, just its sign. And then so we get concave up. Concave up. So you see that? Concave down. So I'm just going to label this as CD. Concave down from negative infinity to 1, and then concave up from 1 to infinity. Alright, so this follows the same pattern, just like we were doing in I just now realized something. We were actually looking for the inflection point, weren't we? Okay, that's okay. We just did an extra step. The actual inflection point, what you'll want to do now is look at this number here, and since it's concave down and then concave up, you'll take this 1, so the inflection point is actually 1 and then f of 1. Okay, I just now realized we're not talking about concavity in this problem, but that's okay, we needed to know it anyway. Alright, so this is your inflection point. Let's go over, so 1, and then when we plug that in, we'd end up getting 3, as you can see here. Alright, so but we need to check and make sure that's right. Okay, there it is, 1, 3. Alright, so come on over. We did a little extra in that problem, but come on over to gotomath.com and check that out. Alright.